Have my audience of 5 ready for submission. Okay. Alright, hello, good morning. My name is Caitlin Murphy. This is my informative speech submission on the ocean's changing climate conditions and progressive trends on today's date, October 3rd, 2014. Earth, appropriately referred to as the blue planet. Covering over 70% of the Earth's surface, the ocean is the largest habitat on the planet, containing 99% of the living space. This vast area supports the life of nearly 50% of the Earth's known species, making it habitat to the greatest diversity of major plant, animal, and microbial groups on Earth. Human interactions with the environment have brought on increased concentrations of greenhouse gases being released into the atmosphere, mostly deriving from the combustion of fossil fuels, which includes natural gas, oil, and coal. Over the course of several decades, scientists have come to observe correlating cause and effect patterns between the levels of carbon dioxide present in the atmosphere and fluctuations of oceanic surface temperature, oceanic acidity, and rising sea levels. According to the Environmental Protection Agency, as greenhouse gases trap more energy from the sun, the oceans are therefore absorbing more heat, resulting in the sea surface temperatures and the rising sea levels. And although the oceans do help to reduce carbon dioxide by absorbing it, the increased carbon present in the ocean waters is actually changing the chemistry of the ocean itself, which is then causing it to become acidic. All right, so our first demonstration will be on surface and depth temperatures. Again, according to the EPA, as the sunlight strikes the Earth's surface, the ocean reflects, absorbs, and stores some of this heat. Considering the properties of liquid water, it has a much higher boiling point compared to that of the atmospheric gases, which means that the overall change in temperature would actually be extremely slight. However, data graphed from 1880, over time the average surface temperature has undergone some very noticeable changes. Between 1901 to 2013, temperatures rose to about 0.13 degrees Fahrenheit every 10 years. This graph was provided by the National Oceanic and Atmospheric Administration for the EPA website. It provides the 1971 to 2000 average as a baseline for increasing factors. And then this gray area is more or less just data error up until about 1950, where we can assume that the technology became more precise and accurate as far as measuring the changes in surface temperatures. In the Coral Seas episode of the Blue Planet documentary series, the narrator explains that coral reefs provide the foundation on which entire reef communities rely upon. Within that community, one of the strongest mutualisms that exists is actually within the coral reef skin itself, where millions of single-celled algae survive. And what they do is they photosynthesize using the light that comes in through the surface, which is how the coral obtains 98% of its food. The amount of sunlight matters tremendously for the survival of these algae cells. So much to the point that the NOAA states that prolonged unusually warm oceanic temperatures can result in the expulsion of those algae cells, which causes the coral to bleach white. But when a coral bleaches, it doesn't necessarily mean that it's dead. They can survive the traumatic events, but it does mean that the coral is under a tremendous amount of stress, thus making it more subject to mortality. Again, ocean temperature is not the only thing that causes a coral to bleach. All right, moving on to sea level. Again, demonstrated by the NOAA. Sea level and the temperature of the Earth are very close correlating factors. Since the 1900s, the seas have been steadily rising about 1 to 2.5 millimeters every year. Water expands as it becomes warmer, another property of water, which means that the entire ocean volume has been expanding with it as well. But heat isn't the only thing that that goes into sea level. Another thing that can be considered is the melting of glaciers and ice sheets. The EPA also explains, let's see. Okay, so provided by the EPA, this indicator describes change in glacier mass balance, which is basically the thickness of the surface of the glaciers. The Glacier Monitoring Service has been observing like the standard 40 glaciers from 1980 to present, and this information is the decrease in water. It's been converted to the amount of liquid water. Okay, so the reason why this is important. The EPA also explains that sea levels can affect human activities in coastal areas. Rising sea levels overwhelm low-lying wetlands and drylands. It erodes shorelines and contributes to coastal flooding. And also makes coastal infrastructure more vulnerable to damage after storms, which is basically what the country witnessed when the levees broke in New Orleans after the hit of Hurricane Katrina, which is demonstrated by this image over here on the right. Okay, so last point is the ocean acidity. Again, demonstrated by the EPA. Over the past 250 years, the oceans have absorbed about 28% of the carbon dioxide that's been produced by human activities that burn fossil fuels. This figure shows the relationship between the ocean carbon dioxide levels, which is demonstrated here on the left, and the acidity, which is measured in pH. Notice it's in a range of the low pH 8 values. These come from two observation stations out in the North Atlantic, which is the Bermuda and Canary Islands data, and then there's one in the Pacific, which is where Hawaii's hanging out at. So as carbon dioxide levels rise, acidity decreases. Now, to get like a better idea as to like what this actually means as far as the ocean, seawater is supposed to be at a pH level of about 9, which means that it's actually hanging out in this area. As carbon dioxide reacts with seawater, it produces carbonic acid, which is what causes the water to become more acidic. Changing the balance of minerals in the water, it does make it more difficult for corals and other creatures to form a mineral called calcium carbonate, which is the basic mineral of their skeletal structures and their shell structures. So overall, conclusively, the data collected by the U.S. Environmental Protection Agency and the National Oceanic and Atmospheric Administration provides grand and specific insight into the relationships between human activity, the atmosphere, and oceanic conditions. The trends on the graphs lead us to determine that greenhouse gases are contributing to the rise of oceanic temperatures, sea level, and oceanic acidity. But for any additional information, you can visit the EPA website at epa.gov/climate change, or you can visit the National Oceanic Administration at oceanservice.noaa.gov.